Hey everyone, Mr. Kim Singh here, and today I want to be talking about shape and modality of datasets. And give me a sec. Guess I don't need these glasses anymore. Hey, all right. So I want to be talking about shape and modality of datasets, right? And when we talk about calculating measures of central tendency and measures of spread, I guess we're really interested in actual values, and we call these summary statistics, right? They're giving us information, a numerical value, which gives us information about a data set. But sometimes we don't need to know that. Sometimes we don't need to have exactly that, fine detail about each and every single one of those values. We only necessarily need to get a bigger picture of things. The way I think about it is like connecting the dots, right? So back in the day, I used to do all of these connecting the dot things, and sometimes you're not really interested in each of the minute placements of the dot, but you're kind of interested in taking a step back and seeing what this is going to look like. And some of them are really easy to interpret, right? And some of them are really easy to interpret. Like I know this guy's a Stegosaurus. I'm just kidding. I know it's a Triceratops. But some of them are a bit trickier, right? Like I wonder if anyone can work out. Leave in the comments below if you can work out what this guy is over here. Not as obvious, right? Because the issue is if we get crowded by all these numbers here, we kind of lose a sense of what's actually going on in a big picture sense. So that's why we're sometimes interested in the shape and the modality of our distributions. Okay, so I want to give you a few different terms to define, and we're going to give you examples of what these all refer to. And just as a note, we're actually working with what we call distributions now, and they're basically a continuous line which represents the frequency of each of the values, and it's kind of like an approximation. The reason why I talk about that is when we think about the mode, we always think about what's happening the most often, and that's true. But when we're talking about the modality of a data set, we're not necessarily looking at the one that's just happening most often, but we're looking at the general shape of it. So let me give you an example. A unimodal data set, as the name suggests, if you think about uni, that just means one. Like if you think about unicycle or something like that, then that's just one wheel, right? So if I have a unimodal data set, it's just something that looks something like this. There's like one peak, we say, right? So there's one peak there, okay? A multimodal data set, oh, sorry, I skipped one. A bimodal data set, again, as the name suggests, if you've got bi, that's like a bicycle, right? Then I've got two peaks. And when I talk about peaks, I'm not necessarily saying they have to actually be the same size per se, right? I could actually have something that looks like this. This would also be considered a bimodal data set here, right? Because there are these two peaks that are occurring. There's a peak, and there's also a peak there, okay? And then, as the name suggests, multimodal, that's just going to be one with many peaks, and that could look something like this. Okay. Right. So as long as these are kind of separated and there's some like clear distinctions between each of these peaks, then we count them as separate ones. Now that's modality, right? We're looking at the frequency, ones that have a particularly high frequency, but the language I'm using is that we're looking for the peaks, basically. Now, another way we can describe the shape of a data set is in its distribution. Now, if you continue to learn mathematics in the future, you'll learn there are a lot of different types of distributions, but we're just going to focus on looking at the normal distribution and also something called the skewness. So the normal distribution is a common distribution which is quite special because it's actually quite even, right? You can see here that there's a single peak here, and when I say even, it's actually quite symmetrical as well as another way to describe it, and that's what they call it. It's a symmetrical distribution or a normal distribution. There's also another name for that. I'll come back to that in a sec. Positively skewed. Now, when we talk about skewness, the way I want you to think about skewness is, if something's askew, it's kind of to the side, right? But how exactly do we describe the skewness of a distribution? A positively skewed data set looks like this. And the reason it looks like this is because you can see it's been kind of shifted to one side. compared to the normal symmetrical distribution. And the way that it's been shifted is I want you to think about where the tail end is. Where are the like lower frequency amounts? Because remember, this represents the frequency. And the lower end parts are over here to the right side. Okay, because if that's the frequency is the height, then if it's lower, then it's going to be less frequent. And that's what we call the tail of a distribution. And depending on which direction this tail is, that's how we determine our skewness. So because this is, if you think about your number line, the negative numbers are to the left, the positive numbers are to the right. We call this one positively skewed because the tail is towards the right side. If I'm looking at something that's negatively skewed, then it's just going to be the opposite, right? So if I have something like this, so this guy over here, there's your tail, okay? And that's to the negative side now, right? Even if it doesn't necessarily have negative values, we're just looking at which side it falls on, so it's to the negative side. That's why it's negatively skewed. Now, the other name for this kind of distribution is that at the beginning that I talked about is that there's no skewness because it's kind of perfectly balanced, right? So that's another thing that we can refer to as well. Okay, so those are the different types of modalities and skewnesses. All right.